Hello viewers, I'm Kausalya. Today we are going to solve problem related with mesh analysis. The problem here is, in the circuit shown in figure, find the power delivered by 4 volt source using mesh analysis and voltage across the 2 ohm resistor. So here this problem is a bit different. Here we are going to use combined super mesh equation because here we have voltage sources as well as current sources together in a circuit. So here this is the given circuit diagram. We have to find the power delivered by the 4 voltage source, right? Here is our 4 voltage source and the next one is voltage across the 2 ohm resistor. We need to calculate. So here, since we have source currents, we are using the super mesh technique. Okay, the super mesh technique is a bit different, but it is quite easy to adapt. So here we are going to write the super mesh equation. Here the super mesh equation is nothing but while writing the equation, we will be eliminating the current sources. So here in this circuit diagram, we have two current sources. So one is 5 amps and another one is V2 by 2. So these two are the current sources. We are going to eliminate this current sources and then we are going to frame the equation. So here as usual the same thing. Here we have 3 loops. So obviously here we will be having 3 loop currents. So here let the currents be I1, I2 and I3. So when you look at this first part, you see here the current flowing through this 2 ohm and this 6 ohm resistor is I1. And even if you want to simplify also, no need to simplify because we need to find a voltage across this 2 ohm resistor, right? I think of telling since these two resistors are series we can add, but don't add because we need the voltage across this 2 ohm. So here it is given as V2. So first write down the equation. So here 2 into I1 plus 6 into I1, and here you see when you consider this 4 ohm, here I1 flows like this and I3 flows in opposite way. Therefore, it is plus 4 into I1 minus I3 because first we are giving importance to our first loop. Therefore, here first we have to write I1 then I3. Right. So 1, 2, 3. The first loop has 3 resistors and we have written 3 values. And the next thing here is, you see, okay, we write expression for this resistor and this resistor. And you see here I have a current source. So I have to neglect this as well as this one. Now I have to write equations for this resistor and this resistor with this voltage. So when you look at this resistor, so here in this resistor is common for loop 2 and loop 3, and again here 2 currents flows. So therefore I3 flows in this way and I2 flows in opposite way. Therefore, since we are considering our loop 2 now, here I am writing it as I2 minus I3 into 1. Right. Now again when you look at this part, to this 5 ohm only the current I2 flows. Therefore here it is plus 5 I2. And finally when you look at this voltage source, here it is moving from minus to plus. So I am taking this part as minus 4. Or else the entire equation voltage drop, okay, these 5 things contribute the voltage drop and this is your voltage rise. Or you can write these 5 terms together which is equal to 4 volt, right? Or if you write in the same side, you have to write it as minus 4 volt. Wait, let me show you here. Am I making sense here? You see, while writing the equation, it is 2I1 plus 6I1 plus 4 I1 minus I3 because this is common for loop 1 and loop 3. I am writing expression for loop 1 first. Therefore, here I have to write it as I1 minus I3. Okay, first 3 terms. Now, we are gradually moving to this side because here there is a current source. I am rejecting this. And when you look at this 1 ohm, this is common for loop 2 and loop 3. Now I am proceeding with loop 2. So I am writing it as I2 minus I3 into 1. So this is what it is written here. And the next thing is, to this 5 ohm only I2 flows. Therefore 5 into I2 right? And here I am writing this as minus 4, or else you can simply move this minus 4 to the right hand side and you can write it as plus 4. That is 1, 2, 3, 4, 5. These 5 things are voltage drops and this 4 is a voltage rise. Right. So this is as per Kirchhoff's voltage law. Now this is fine, right? Now we are going to simplify this equation. So 2i1 plus 6i1. So 2 plus 6 gives you 8i1. Again I am multiplying this 4 with i1 and i3. So 4i1 minus 4i3 plus i2 minus i3 minus 4 plus 5i2 equal to 0. So here again when you simplify, 2i1 plus 6i1, 8i1 and plus 4i1. So again when you simplify, finally we end up with, you see, 12i1. And regarding i2 terms, I have 5i2 plus i2, 6i2. And this 4i3 and i3 minus 5i3, which is equal to 4. And name this as equation 1. Right. So again, you see, in branch BC, okay, in this part, I am having a 5 amps current. So again, you see in this part also we have two currents which are flowing, right? Because you see I2 flows like this and I1 flows like this. So here I am writing the equation as I2 minus I1 because I2 and this current are in the same direction. Therefore, I2 minus I1 is equal to 5 amps, right? So write this equation, let it be equation number 2. And finally here I3. So I3 is nothing but V2 by 2. Right. So what is V2? V2 is nothing but voltage drop across this 2 ohm resistor. So here V2 is nothing but 2 times of I1. Therefore, here just substitute the values. V2 is 2I1 by 2. And again this 2 and 2 they cancel each other. And finally the value of I3 is equal to I1. Right. So these are all the basic equations. Now we have to simplify these equations. 12i1 plus 6i2 minus 5i3 is equal to 4. So now I2 is nothing but I2 can be written as 5 plus I1 because here we have the relationship I2 minus I1 is equal to 5. Therefore, I can replace I2 by, you see, you need I2. So I am moving this minus I1 to the right hand side. So it becomes plus I1. So I2 is equal to 5 plus I1. So just substitute here. And here again I3 is nothing but I1. So I3 is replaced by I1 here. Because now we are going to calculate I1. So only we are transforming, we are rewriting I2 and I3 in terms of I1. So again when you simplify, 6 5s are 30 and 6 into I1, 6I1 and here minus 5I1. So here it becomes 1, right? 6I1 minus 5I1, simply I1. So 12I1 plus I1 gives you 13I1, which is equal to, here it is 4. I am moving this plus 30 to the right hand side. So 4 minus 30, which gives minus 26. And again now I1 is nothing but minus 26 by 13, which is equal to minus 2 amps. Now we have calculated the value of I1. From this we can easily find the value of I2. So I2 minus I1 is equal to 5. So I2 minus I1 is minus 2, right? So minus of minus 2 gives you plus 2 equal to 5. So I2 is 5 minus 2, which is equal to 3 amps. Now we know the value of I1 and I2. So we can calculate the value of voltage across the 2 ohm resistor. So voltage across the 2 ohm resistor is given by 2I1 because this is clear from the problem, right? Let me show you. So V2, voltage drop across the 2 ohm resistor is V2, and what is the current that flows through this 2 ohm? It is I1. So V2 is equal to 2I1. So V2 is 2I1. What is the value of I1? I1 is minus 2 amps. So 2 into minus 2, which is minus 4 volt. And power delivered by the 4 voltage source. So power delivered is given by, P is given by V into I. So here voltage value is 4, and what is the current that flows through this 4 voltage source? Again you see, the current that flows through this 4 voltage source is I2. Therefore power is given by 4 into I2. So 4 into 3, which is equal to 12 watts. So here What does this negative sign indicate? This negative sign indicates that the direction of the current is opposite. Right, that's the thing. So if the direction of the current is reverse, then the value of this I1 will be plus 2 amps. So this problem gets over here. If you have any doubt, let me know in the comment section. Thank you.